we said that average rate of change, it is when we it's a little bit bigger. If we have a curve y is equals to x squared, this is a curve, and we draw this, what the behavior we get from this behavior. Now we have 2 points, Q and P. So average rate of change between P and Q is the gradient of the straight line joining PQ. That's what we agreed yesterday. And in an instantaneous rate of change, it is the rate of change at curve of the curve at t, at x, at a point x is equals to 2. We draw a tangent to the curve at x is equals to 2 and establishing its gradient. That's what we agreed yesterday. Now we wanted to determine the gradient. Let me enlarge this circle. So in this table, we are seeing a position of Q, because Q keeps on moving. When Q is at 2, 4, the change in X, remember our point P is 1, 1. Then now let's create the idea where it is coming from. From this graph, we have a point P. We have a point P, this one, which is 1, 1. And then we have another point P, Q somewhere, Q1. We have another point Q. So along this curve, Q can keep on moving downwards to Q1, then to Q2, as it is approaching P. And now you can see that the line PQ has a certain gradient. Another line PQ1 has a certain gradient, change in Y, change in X. Another line PQ3. So Q will keep on moving closer and closer to P, and then we determine their gradients. So this is where we are. So this table is illustrating the same, that Q can keep on moving close and close to. So this is position of Q as it approaches position of P, which is 1, 1. And what will be the gradients? So the gradient when Q is at 2, 4, change in X is 1, that is 2 minus 1. Change in Y is 3, that is 4 minus 1. And now the gradient is 3 over 1. change in y over change in x. And the q moves closer to p, and then we have change in x, change in y, gradient change in y over change in x is equals to 2.5. You do the same, gradient, we get 2.1. When q is moving very close to 1, 1, now it is 1.01, 1.0201. Change in x, change in y, gradient 2.0, and q moves much close to p, change in x, change in y, change in gradient is equals to 2.00. As we start from this level downwards, the gradient tends to become 2. It's almost becoming 2, because if you round off to nearest odd number, you are getting 2. And as we are moving very close to to p, still the only what is increasing at the decimal points, but the needs the same. The value before the decimal is 2.2.2. So it is almost the same. So let's now do some conclusion. So in this case, from the table, notice that as q moves closer to p, the change in x becomes smaller. Chord pq tends to be attached to the curve at p, and the gradient of pq tends to 2. Thus, the gradient of a curve y is equals to x squared at the point is 2. We can use similar approach to do the same. Now let's go to what we did yesterday. So the gradient at 2, gradient of the curve y is equals to x squared at the point 1, 1 is 2. And remember yesterday we did what? We said dy dx of this one is equals to 2x. That's what from what we did yesterday, this is what we get. So meaning, when x is equals to 1, the gradient is equals to 2, because we substitute 1 instead of x, we get 1. So 2 times x, 2 times 1 is equals to 2. We shall still see more. Gradient of y is equals to x power n. Now we want to see a general form of this function y is equals to x to the power of x to the power of n, where n is positive integer. Now, how are we going to deal with the same? We are not going to follow through the process of small changes. Let us go to what we agreed yesterday. And in yesterday we said we were at this level where we said that if this is the function, then what we get is the gradient function. A function for the gradient, which is gradient, we know it is change in y over change in x. So change in y and change in x, when y is equals to 2x squared, gradient function dy dx is equals to 2x. When y is equals to x cubed, gradient function becomes 3x squared. This is what we did yesterday. And then we made an assumption that if that is the case, if y is equals to x power 5, Then dy dx, the derivative of this one, will be equals to, we multiply 5 times 1, the coefficient of x, we get 5, and then we have x, we reduce the power here by 1, so to the power of 4. That is the general statement we made yesterday. So in general, the gradient of a function of y is equals to the power of x power n is given by x to the power of n minus 1. So the gradient function is called, this is what I want us to get. Gradient function is called derived function. These are other terms. And or it is also called the derivative. When we say derivative, when we say derived function, when we say gradient function, we are referring to the same thing. And then we said it can also be denoted as y prime. Y prime, it can also be said to be change in y over change in x, but normally we are going to call it dy dx. All these things, dy dx, y prime, derived gradient function, derived function, derivative, we shall be referring the same thing. Now, what is the definition of differentiation? So differentiation is a process of obtaining, so the gradient function and whatever, the process of obtaining the derived function, process of obtaining the gradient function, obtaining derived function of a function is called differentiation. So differentiation, it is a process of obtaining derivative function, process of obtaining gradient function, process of obtaining a derived function from a curve, from a function. This is the one we call differentiation. So y to the power of y is equals to x power 5 is differentiated to the result. The result is 5x power 4. Did I say I share my screen?
Yes.
Good. We are simply going through what we did yesterday, a recap of the same, and next. So differentiate the following. If we want to differentiate this one, we are likely to, how can we get differentiate each of the following? This is y is equals to, so what will it be? Dy dx of the same. This one, obviously it will be what? Maximilian?
6x to power 5. 6x to power 5.
6x to power 5, good. And 6x to power 5. This one will be, Sarah?
9x to power 8.
This one will be equals to, Christine? Christine, communicate. Abuya, Lydia.
Could you experiment?
Mm-hmm.
Could you experiment?
20x power 19. Abuya, Lois.
Negative.
Oh, no, who was speaking?
Negative 3x.
Negative 3x
Or negative 2.
power negative 4. Where are you getting negative 2 from? What is 3? Negative 3 minus 1?
4.
4. Negative 4. Good. This one? We are following the simple process. Y is equals to x power n. It is the derivative y dx is equals to n x n minus 1. It's a general form. That's what we are applying. So this one will be, Christine, I'm back to you. 1 over 2 x. We have multiplied this one here. Negative 1 over 2. This one will be equals to negative a half x negative a half minus 1. I'm simply going faster, but we are observing this one. Multiply by the power, decrease by the power by 1. Okay, that's what we... Anybody has a question here? No question. Now let's go to another level. Delta notation, annotation, it will just sort out itself along the way. I want us to go to derivative of a polynomial. How are we differentiating a polynomial? We are here, not a polynomial. This is the first term. Differentiate each of the following functions. We are still finding the change in y over change in x. So for this one, we simply multiply. Now the coefficient is not 1. So dy dx will be equals to 12x power 2. The same case here. Dy dx will be 12 times this one minus 6x to power 11. This one will be equals to, we multiply this one here, will be 2 over 3 times 3 over 4 x 3 over 4 minus 1, and this one gives us by 3 by 3 by 2 1 by 2 2. So I have, it's just a simple process. X 3/3 minus 3/4 minus 1, it is negative 1 over 4. It's quite simple, but if we have just a concern, you can raise along the way. We are just familiarizing ourselves with the process of differentiation. Anybody has a question here? No question. So we can see the solutions. 12x squared, negative 6x to power 11, and a half x to the power of negative a quarter. Differentiate each of the following. It's quite easier. Let's go to derivative of a polynomial. A polynomial is a statement, is now an equation that has a function that has more than one term. So a polynomial is x is an expression of this form: a0 x power n, a1 x power n minus 1. So the power is decreasing by 1 until we have a power n. So that's the so where n is a positive integer, these are constants. Well, example, for example, an example of a polynomial is this one: y is equals to 2x cubed plus 4x squared minus 5x minus 7 is a polynomial. So if we consider this one as our polynomial, consider the derivative of y is equals to consider the derivative of y is equals to 4x squared plus 3x plus 2. Two general points on the. So we are not going to go through the process of derivative due to smaller changes, but we don't require that one. Let's go to the general statement. So if this is the gradient function that we have, if this is the polynomial, let me check whether we have somebody lost somewhere. Tiffany, you are always late. What's wrong? No, whatever we have covered, it can take you time to, but it's exactly what we did yesterday. So you are most welcome. Good. We are doing a derivative of a polynomial, and we have described what a polynomial is. A polynomial is a statement, an expression that has more than one term. For example, y is equals to 4x squared plus 3x plus 12. This is a polynomial. Y is equals to x cubed minus 2x squared plus 7x minus 4. It is a polynomial. Y is equals to 3x squared plus x squared cubed minus x is a polynomial. Now, how do you find it is gradient function? How do you find it is change in y over change in x? How do you find it is derivative? How do you find it is derived function? How do you find it is the y prime? Because we are using the same terms to refer to the same thing. So gradient function, I want you to take note that when we differentiate this, is the derivative of the first term. The first term is 2 times 4, 4x. Then we reduce the power by 1. So 8x. 3x, it is the derivative, its derivative is 3. That is, if we have 3x to the power of 1, then we differentiate. It means we multiply this one by 1, we get 3. Then we reduce the power by 1. So this one gives us 3 to the power of x to the power of 0. And this one gives us 3, because anything raised to the power of 1, it is always 1. So differentiating, this one becomes, differentiating 3x becomes 3. X disappears, but it is there. Only that the power, it is the one which is 0. So differentiating 12, when we have just a constant 12, 12 means that there is 12 to the power of 0. So if we multiply 12, the derivative will be 12. Somebody is coming this late. Maximilian, you are back. So when we have 12 in a polynomial and we want to differentiate it, it means that it has 12 to the power of 0. Only that we don't include x to the power 0 because it is 1. But now let's differentiate 12x to the power 0. 12x power 0, 0 times 12, 0. X, 0 minus 1. Anything multiplied by 0, it is always 0. So differentiating a constant becomes 0. So this one plus 0. And there's no need of indicating a 0. I want us to make that observation. Let's move to the second scenario. Then we do a conclusion. In a second scenario, because we know that the proper way of doing the differentiation, so the derivative of the first term, it is 3x to the power of 2. 3x to the power of 2. Derivative of the second term is negative 4x. Negative 4x. Derivative of the third term, it is 7, because it is 7x to the power of 1. The derivative will be 7 times 1, x to the power of 1 minus 1, which is 7 to x to the power of 0, where x to the power 0 is 1. So differentiating that one gives us 7. Differentiating a constant, it will always become 0. Same case here, derivative of 3x to the power 4. Somebody is popping in. Okay. Christine, you are back. And so differentiating 3x power 4 becomes 12x power 3. Differentiating x power 3 becomes 3x power 2. This one I make an assumption that we all know the process of differentiation. Differentiating x minus x, it becomes 1. We still illustrate y1. It is x to the power of 1. Multiply 1 here. 1 x minus 1 here. 0. 0 is always 1. Anything to the power of 0 is always 1. So x times 1, it gives us 1. So what are we doing here in general? When we are differentiating a polynomial, note that the gradient function of each of the polynomials could be obtained by differentiating it, each term by turn. Let us say by differentiating it, each term by turn. So in general, the derivative of the sum, the derivative of the sum of a number of terms is obtained by differentiating each term in a turn. So we differentiate a term in turn. That's how we differentiate a polynomial. So to differentiate a polynomial, differentiate each term in turn. Now, we have been working on expressions that are ready for differentiation. So, it is not all expressions that are always ready for differentiation. Some expressions may not be that ready for the process of differentiation. So we need to treat them until they take the shape that we can differentiate. For example, this one. This is expression. This is the equation y, a function y. It is equals to x plus 2, x minus 1. This expression cannot be differentiated the way it is. So we need to expand before we differentiate. So one of the processes, it is to expand before you differentiate. So you cannot differentiate an expression unless it is in expanded form. So expansion means we multiply and then we get the expansion of it, which is y is equals to x squared plus x minus 2, and now then we find it is dy dx, which will be differentiate this first term 2x, differentiate the second term, it becomes 1, and differentiating a constant, it always becomes 0. So expand before you differentiate. Another expression is of this form, and this expression, it has a common denominator. So this expression here, we simply, it is not a polynomial because this is a single term. So it is not a polynomial. Okay, the numerator might be having some terms, some 3 terms on the numerator. But the moment everything has been expressed under common denominator, it becomes a single term. So we cannot differentiate the way it is. So number 2, we separate the terms before we start the process of when it is a fractional function, we separate the terms. Here we separate the terms before we take the process of differentiation. So separating the terms, we simplify. So this one is like, let's see the genesis of this one. This is the same as x cubed over x plus, because the denominator is the same, x squared over x plus x over x. Alternatively, you can go to the numerator and factor out what is common. X is common. So if we take out x is common, what will remain is x squared plus x plus 1 over x. So this x and this x will cancel, and then we remain with x squared plus x plus 1. So this expression, and here we can cancel, x moja inaenda na x ingine. So after expanding and simplifying, this is after separating and simplifying, this is what we get. Now at this stage, the expression is ready for differentiation. So we can now find change in y over change in x, dy dx, which is equals to 2x plus 1, differentiating the first term and differentiating the second term. Good. Another expression. So number one, we have said expand before you differentiate. Another one is if it is under the common denominator, separate the terms under that common denominator, simplify, and then differentiate. Find the derived function of each of the following. This one is quite straight, but it is informing us one thing, that is not a must we are going to get the derivative of to get a function in terms of x. Sometimes a function can be in terms of other letters. Other letters, for example, here we have an expression of s is equals to 2t squared minus 3t squared plus 4t. So here we are not going to say, if we want the derivative, we are not going to say dy, we are going to say ds over dt. That's the communication, because we are differentiating the expression, the function ds s with respect to t. So we take what we have on the left hand side as our, that's the equation, that's the subject of that function is equals to what we have on the other side, left side, right side. So we are differentiating t with respect to time. So and we differentiate that one. On the second one, we are going to say we are finding the derivative. We are finding dv against dr. So we are differentiating v with respect to r. And this one we are going to say we are differentiating a with respect to v. So dv is equals to, but the process of differentiating remains the same. For example, differentiating the first term, we get 2v minus differentiating the second term, we have 2. This is the derivative. So the letters can change. It's not a must we are going to have every time a function in terms of y and x. Very good. And that's what we have as the solutions. So we have differentiated a polynomial. You multiply this one here, 3 and 3 will cancel, 4 pi r squared. Differentiating this one, we get 2v minus 2. And now I want us to do a certain exercise. There's somebody here by Shamian. You are welcome. We are doing differentiation. You are late, but I will upload the what we have discussed somewhere and share the link. Okay, tutasalimia baadaye. Let's continue. I want us to go through this. For example, we are told we are given some statements here that I want you to take note of. Differentiate the following with respect to x. It means on the right hand side we have a variable x. So we are differentiating y with respect to x. That's the communication. So what we are finding here, it is dy dx, which is very simple. I want you to differentiate and then we share the answers. I've given you 2 minutes. I can allocate every one of you one. Let me allocate. I will allocate this one.
Yeah.
Yes.
Can you reshare the screen?
Oh, it is the screen is nowhere.
Yes.
All right. Now you have the screen, Biffan?
Yes.
Good. So we want to differentiate this one. Let me allocate the questions. Christine will do the first one. Lois will do the second. Lydia will do the third. This is Lydia, Lois, Christine. Sarah, you will do part D. Tiffany will do part Y. And Shamian, you do question, the last one. I've given you 2 minutes. Kila mtu achangamkie yake. Okay, I want us to share the answers. Tuanze na Christine. Soma yako. Let's start by saying dy dx. This equals to still we are not hearing you.
Three.
The process of dy we said if excuse me, y is equals to x power n. Get this process. dy dx would be equals to multiply this n here. If this was ax power n, so it will be n times an x. Reduce this power by 1, n minus 1. That's the process of differentiation. So Christine, what is dy dx? Dy over dx is equals to what? Christine is not talking. We were at Lois. Next was Lois. Dy dx.
Dx is equals to 4x cubic minus 6x.
4x cubed minus 6x. That's all, right? Good. Lydia?
20x cubed minus 10x power 4 minus 21x cubed.
20x power 3 minus
10x power 4.
10x power 4 minus 21x power 2. Good. Next is Sarah.
Negative 10x power 19.
10x power 19.
X power 8. Then minus x power 8.
Minus x power 8. Good. Tulikuwa na Maxia Manan. Who was next? Epiphany was next, eh?
Yeah. 28x to power 6.
28x power 6 plus
6 over 7 x to power 5.
Power 5 minus
3x to power 2.
Power 2. Shamil. Shamin.
4x power 3.
4x power 3 plus well, we are not saying next. Well, hii maneno mumeanza kuileta hadi plus x. We said differentiating this one there is 1 here. 1 times 3, 3. X. 1 minus 1 is 0. Anything raised to the power of 0 is 1. So it's like 3 times 1. So we remain with 3. Differentiating a term that has a... Just obey the process and it will lead you somewhere. Back to Christine.
12x power 3.
12x power 3. And differentiating a constant becomes 0. That's how we differentiate a polynomial. And now I want us also to do just one thing. There's one exercise before we do something else. There's an exercise here. Question 8. Question 8, it is it has expressions. Okay, the question is saying find dy dx. In other words, find the derivative. This expression needs some preparation before you differentiate. Same case here, some preparation before you differentiate. This one, the same. I want somebody to choose one that you want us to attempt. As you will go and as I will assign you others, you go, you differentiate, and we share the results. Choose one you want us to but I can give you some highlights. This one needs us to factorize the numerator. Factorize the numerator. Some terms will cancel and you differentiate what will remain. That's the process. Factorize the numerator. You get x plus 2 x plus 2 over x plus 2. This bracket will cancel with this bracket. Now we remain with y is equals to x plus 2. This one can be differentiated. So we have seen, think on a way that you are going to get a linear statement. B, you will expand. Expand before you differentiate. 3, separate the terms before you differentiate. Separate the terms. So we want to have x power 4 over x power 3, 2x power 3 over x power 3, 3x power 2. Then after that one, for example, we want to get somewhere, we after separating, we are going to have a statement like this one. We get as 3x power 2 over x power 3. This statement will lead to 3 over x. Still, we cannot differentiate if x is on the denominator. It goes to the numerator, so it becomes 3 power x negative 1. You bring them to the numerator. This one you will you expand the numerator. After expanding the numerator, then express to the separate. This one is expand numerator, then separate terms. I know you want to encounter something of this kind. This one calls for expansion, and now like terms together, the expression will be ready for this one. Factorize the numerator, and the x plus 1 is going to cancel somewhere. This one expand, then differentiate. This one expand and remove this radical. This is the same as x to the power of a half. Instead of saying root x, you can say x to the power of a half, then expand, later differentiate. This one expand the numerator, separate, and then differentiate. Now I want you to choose one that we will work out. Maximilian, I have the privilege of choosing one. You are choosing one expression for us to
I choose
zimekuwa nyingi. Choose until they say you have made the right choice.
I.
You choose I.
Yes.
Sarah, are you in agreement?
Yes.
Good. Let's see I. This expression cannot be differentiated the way it is. So we need to to arrange it. Let us expand the numerator. X squared plus x times x negative 2 plus 1. X squared times x negative 2. The base is the same, x. Then you add the indices. 0 plus x squared times 1 x squared, x times this one plus x, the base is the same, add the indices, negative 1, this times this one plus x. This one becomes 1 plus x squared plus x to the power of negative 1 plus x. This is the expression we get after we have expanded the numerator. Then separate the terms, because everything is under the common denominator, x squared. Separate the terms, 1 over x squared plus x over x squared plus x power negative 1 over x squared plus x over x squared. We don't want to see anything on the denominator. Of course, others will cancel out. Like this one, 1x will cancel with 1x on the denominator. So we are going to remain with the 1 over x squared plus 1 over x. This one is hata ibaki vile iko. This one, when it is x power 1, it means it can go to the denominator and become 1 over x. Using indices, x to the power of -1, it becomes what? X over 1. 1 over x. So here what we have is 1 over x.
Sir,
Yes.
the second term was x squared.
Our second term was x squared. Oh, hizo zinaenda zote. Good. So we remain with what? 1. Si ndio? Then this one goes to the denominator, itakutana na zingine mbili hapo. So it becomes x to the power of 3 plus x will cancel with x, will remain with 1 over x. And that's all. Then we don't want anything to call the x on the denominator. So take everything to the numerator. So we have x -2 plus 1 plus x -3 plus x to the power of -1. Now this expression can be differentiated. So this one now will have the derivative of e itakuja hapa, si ndio? Hata niame huku. So we have the expression y is equals to x power -2 plus 1 plus x power -3 plus x power -1. This expression now can be differentiated. Let's differentiate. So we get change in y over change in x will be equals to e itakuja hapa, so -2 x -2 -1 -3 plus hiyo 0 imeenda, and a negative will also interfere with this one. So differentiating a constant becomes 0, so we don't need that one. So we move to this one, x power -3. So you multiply here, -3 x, -3x minus 1 minus 4, -1 times 1, -1 x minus 1 minus 1 minus 2. That's not enough. We move to the, now our answer will be -3. Take this one to the denominator so that it becomes, the power becomes positive, so x cubed minus minus this one, which is negative 3 plus negative 3 over this one goes to the denominator, becomes x to the power 4 plus minus 1 over this one goes to the denominator, becomes x power 2. You can still go further and say this is minus 3 over x cubed minus 3 over x power 4 minus 1 over x squared. Maxi, that's where the journey ends.
Thank you.